So we're going to be talking about finding equations of lines of that are either parallel or perpendicular lines. So whenever we're talking about lines that are parallel, so whatever thing we're doing, so we've got like y is equal to, so we've got y is equal to 2/3 x plus 3. One of the things that we're going to need to do is we're going to need to identify the slope. And if I've got something in this format, this kind of slope-intercept format, I'm sorry, why am I doing that way? This is going to be y is equal to mx plus b, then our, m is our slope. So, and it's very important that it's in this y equals mx plus b format if we're just identifying what our slope is, just like that. Otherwise, we could, of course, just figure out a couple points and plug that in. That's a little bit more work than we really want to. This should be a fairly painless process. Now, a parallel line, what makes a line parallel they literally are going to have the same slope as whatever line you have. So when it comes to this, you're literally going to, if I'm trying to say, okay, let's find a parallel line to this, we just need to use this exact same slope. So in this case, for our example of y is equal to 2/3 x plus 3, I know that my slope is going to be equal to 2/3. And depending on and then the other tools that we're going to use is if we're given a point that our parallel line is supposed to go through, we could use either that point slope formula, which is y minus y1 is equal to m times x minus x1. Or if we happen to be lucky enough to be given a y-intercept, we could also use the slope-intercept form. And that's, of course, y is equal to mx plus b. Just like here. This is our, so these are our go-to formulas whenever we are looking for the equation of a line. These are our go-to formulas. So this is actually going to be both for parallel lines and for perpendicular lines. Now, once we figure out what our slope is and what point we're going to plug in, we just literally plug it in. So here's what we're going to do. I'm going to follow on with this, and I'm going to give us a little bit more information. So let's say we've got our equation here, and we want to find something that is parallel to y is equal to 2/3 x plus 3 that contains the point that contains the point 3, 7. So with this, I'm not given what my sorry, that's a 3. I'm not given my y-intercept, so I'm going to need to use this point slope formula to do that. But from here, I can see that my slope is 2/3, and I've got the point of 3, 7. With that, all I need to do is plug it in. So I've got y minus my y1 is equal to m times x minus x1. So now what's going to happen is I'll just have y minus 7 is equal to 2/3 times x minus 3. I'm going to distribute this 2/3. So I'll have y minus 7 is equal to 2/3 x minus 2, and I'll show you the thought process right there, and just because when we distributed that, 2/3 times our 3, literally, I'm just reducing this. So I've got 2 times 1 over 1. That's going to be a 2, and my signs are going to stay the same because I was multiplying by positive. Last thing to do here is I'm going to add 7 to both sides. So now I've got, y is equal to 2/3 x plus 5. As those cancel out, and -2 plus 7 is 5. This is our parallel line. Now that's a parallel line. Parallel lines are, they're just following along the same path as our other lines. Now, perpendicular lines are just a little bit different. So this is how this would look. Is this would be, okay, 1, 2, 3, 4, 5. I'll have one of these doing something like this, the other one doing something like that. They're literally parallel. They never touch. Perpendicular lines are a little bit different. And the thing with a perpendicular line to consider is if you've got, so a perpendicular slope is the opposite sign as your slope, and it's the reciprocal. So say I have an original slope of, say, let's try 2/3. My perpendicular slope is going to be opposite sign, so positive becomes negative, and I'm just flipping this fraction. So that would be 3/2. If I've got an original slope of, say, let's do negative 4. Well, opposite sign is going to be positive, and I'm going to think of this as 4/1, which means I'll just flip that to be 1/4. If I've got a slope of negative, actually, I'll do a negative 1/3. I'm just taking our sign and flipping it, so that's becoming a positive. And what happens when I flip that? 3/1 is just 3. So we're always changing the sign, and we're just taking whatever fraction and we're flipping it. So a perpendicular slope always has the opposite sign and is the reciprocal. So now I'm going to do another example here where, let's say we're trying to find something that is perpendicular to y is equal to 2/3 x plus 3 that contains the point 0, -5. So here we see that our original slope is 2/3 because we're in this slope-intercept format, which means that my perpendicular slope is going to be -3/2. And if I wanted to, I could use my point slope formula to find the equation, but I want you to note something about this particular point. This point right here, because it starts with a 0, this is our y-intercept. Every point on the y-axis has 0 for an x value, which means that because I've got a y-intercept, I can use my slope-intercept formula. So y is equal to mx plus b. And the nice thing here is everything I need is right here at my fingertips. I've got my y-intercept. I've got the slope I'm going to use for my line. So this is going to be y is equal to -3/2 x minus 5. And we're done.